Given f of x as this algebraic fraction, then told it can be expressed in the form shown, that is, partial fractions. A, b, and c are constants, then we're asked to find the values of b and c and show that a is 0. Okay, so I'm going to let the 50, we've already sort of been told to do this, but 50x squared plus 38x plus 9 over 5x plus 2 squared, 1 minus 2x, be identical to this partial fraction. And I'm going to multiply through by the 5x plus 2 squared times 1 minus 2x. So that gives me 50x squared plus 38x plus 9 is identical to a times 5x plus 2, 1 minus 2x, plus b, 1 minus 2x, plus c, 5x plus 2 squared. Some of the terms are cancelling along the way, but that's what we're going to get. Now I'm going to substitute in some values of x to manage to work out a, b, and c. That's a really good approach to do it. So we can choose for the 1 minus 2x to disappear, i.e. a and b disappear, if x is equal to a half. Then I'll get 50 times a half squared plus 38 times a half plus 9 equal to c 5 times a half, which is 5 over 2, plus 2 squared. Well, 50 times a half squared is actually 50 over 4. 38 times a half is 19. So I get 81 over 2. And 5 over 2 plus 2 gives me 9 over 2. If I square that, 81 over 4. C. Therefore, C is going to have to equal 2. Right, now to make a couple of the other terms disappear, we can let 5x plus 2 equals 0, which means x is going to be minus 2/5. That will cancel out the a and the c term. Be 1 minus 2 times minus 2/5, so 1 plus 2 times 2/5. I can actually ignore the negative because when I square it, it will become positive. So 50 times 2/5 squared plus 38 times minus 2/5 is 9. Gives me 9 over 5. And then actually that equals 4/5 plus 1. That is 9 over 5 as well. 9/5 b. So b is equal to 1. Okay, that was a part 1. Then part 2 is to show that a is equal to 0. There's a couple ways we can do this. A really nice way is to look at the coefficients. Once you've got 2 of them, and we can't now substitute an easy value of x in to eliminate 2, coefficients is a really good way to go. So coefficients of x squared, it must be that these are the same because this is true for all values of x. Therefore 50 is going to equal, I've got 5x times minus 2x. That's going to give me minus 10x squared. So it's going to be minus 10a. If I just look at the coefficient, I don't get any coefficient from the b. So it's then plus 25c. So then 50 is equal to minus 10a plus 50. And that means minus 10a is 0. So a is going to equal 0. Method 2, if you don't like that or if you've never seen that before, okay, there are other ways. We could just put in a different value of x. Let's go with 0. Okay, 0 is a really nice one to put in. So, because on the left-hand side, I just get 9. I'm talking about putting 0 into this. And then I would get 2 times 1 times a, so 2a. then plus b plus 4c, and that would become 9 equals 2a plus 1 plus 8. So 2a is 0, so a is 0 that way. So we've got the partial fractions sorted. Now we're asked to use binomial expansions to show that in ascending order, in ascending powers of x, that f of x can be written as this, first three terms of an infinite expansion. Okay, so I've also written down the binomial expansion formula that we get given. So we do not want to be using this. We want to be using our partial fractions form that we've just found. Therefore, I'm going to write down f of x equal to 2 over 1 minus 2x plus 1 over 5x plus 2 squared. Remember, a is equal to 0, so just those two terms. Let me then write it as 2 times 1 minus 2x to the minus 1 plus 5x plus 2 to the minus 2. I'm going to deal with these one at a time. So first up, this one. Okay, this is nicely already in the right form, 1 plus x to the n. So instead of having x, I'm going to have minus 2x. Instead of having n, I'm going to have minus 1. I just need to do the terms up to x squared. So 1 plus minus 1 times minus 2x plus minus 1 times minus 2 over 1 times 2, I just write 2, times minus 2x all squared. That becomes 1 plus 2x. This actually cancels. I'm going to get plus 4x squared, which is 2 plus 4x plus 8x squared. Then I've got 5x plus 2 to the minus 2. In fact, I want to rewrite that as 2 plus 5x to the minus 2 to get it in the right form. First up, factorize the 2 out because I need to get it in the right form as 1 plus x. So 2 times 1 plus 5 over 2x. And then all of this is being raised to the power of minus 2. Don't forget that. Then that becomes 2 to the minus 2, which is a quarter, times 1 plus 5 over 2x to the minus 2. Okay, ready now. So now this is my x and this is my n. So 1 plus minus 2 times 5 over 2x plus minus 2 times minus 3 over 2, 5 over 2x squared. All times by a quarter, remember. That's 1 minus 5x. Over here, the minus is actually cancelled. The minus 2 and that minus cancelled that 2. So I'm going to get 25 over 4 times 3. That's 75 over 4 x squared, which is then a quarter minus 5 over 4x plus 75 over 16 x squared. Therefore, f of x is going to be that 2 plus 4x plus 8x squared from the first expansion, plus a quarter minus 5 over 4x plus 75 over 16x squared from the second expansion. And that becomes 9 over 4, 2 plus a quarter, then plus 11 over 4x from the 4x minus the 5 over 4x. And then 8x squared plus 75 over 16 becomes 2, you can use your calculator for this, 203 over 16 x squared. Okay, brilliant. And then finally, we're asked to find the range of values for which of x for which the expansion is valid. So this one is valid for the modulus of 2x less than 1. Okay, because remember, it's the modulus of x less than 1, but now my x is actually, what's minus 2x, but you can ignore the minus. So that means I need the modulus of x to be less than a half. Whilst for the other one, I've got 5 over 2, so valid for the modulus of 5 over 2x less than 1. So modulus of x is less than 2 over 5. And I need them both to be valid for the whole expansion to be valid. And therefore, overall, I think this is part 2. It must be the smaller range. The modulus of x is less than 2/5. Okay.